Well, thank you for the invitation to speak here today. My topic is maximizing the value of that other commodity, manure. And so it maybe seems strange for a company where you're mostly dealing with nutrition. Well, manure is kind of nutrition. It's just the opposite end of that nutrition. And so hopefully I can discuss a bunch of different reasons why manure is valuable to the farm and just some ways of managing that manure so that you get that extra value. So just an overview, digging deeper into the pile. Manure adds complexity to a fertilizer management, but it also provides a lot of benefits that commercial fertilizer just can't provide. And so some of those things that we're going to talk about, first of all, just the benefits of manure to soil health. It's hard to put a dollar value on those benefits, so we just want to talk about what is manure doing for the soil. Where does manure fit into nutrient management planning? So we're going to look a little bit at manure and commercial fertilizer and where it fits into the rotation. Manure sampling and manure analysis interpretation, timing of applications so that we can maximize the nutrient value from that manure, and logistics and new technology. We probably won't have time for a lot of those slides. So one of the things that I can say for sure is that the most resilient soils are most often found on dairy and beef farms. And that's because of the manure and the rotation with forages and pastures. And so this is a slide, some of you have seen this before, I'm sure, but this is a slide that came from a study done in the UK. And it started long before any of us were born. So for 20 years, they applied 15 tons of cattle manure to a field, spring grains, and then they stopped. And the amazing thing is, if you follow this purple line compared to the part that had nothing, even after 100 years, there's still yield benefits showing up from that manure application for just 20 years. And the question is why? And I can't answer all of those. But even after 150 years, there's still some benefit. Now, if they had applied manure all the time for all those years, obviously that yield difference would be a lot higher. But that we still have some of this is, to me, amazing. And so what's some of the reason for that? Well, partly, if you look at this red line, that's the line where the manure was added for just 20 years. The green line is where they continue to add it. But the difference is in that organic carbon. And so when we're adding manure, when we've got forages, when we've got crops, perennial crops, we're adding a lot of carbon to that soil. Those microorganisms in the soil make good use of that carbon, and I think that's part of the reason that we're seeing that difference even after all these years. I'm sure there's a lot more to the story, but that's all I have time for right now. But part of, when we add forages, when we add manure, when we add crop rotations, cover crops, we're adding a bunch of different ingredients to the soil. From sugars to cellulose to proteins to hemicellulose, polyphenols, lignin, humus, all of those are ingredients within cover crops and manures. Different amounts in different types of manure. But if I have a liquid hog manure and I apply it to the soil, that's like adding chocolate bars for the bacteria in the soil. They go crazy. If I add solid manure or if I add compost, then I'm going to have far more fungi activity around those root systems. But in reality, the humus, the part of the soil where we're adding that organic matter, is humified by a combination of those microorganisms. So the fungi, the bacteria, the nematodes, the protozoa, the arthropods, the earthworms. And I'm going to show you a slide in a few minutes that shows that a little bit more clearly. But it's a combination. And some of the research that's going on in Guelph now looking at that organic matter shows that when we add manure, when we add cover crops, when we add carbon, it's the microorganisms that are active around those root systems, taking in the photosynthesis that the plant provides, but they provide the nutrients, they build the bigger root systems, and they're adding a lot of that more stable carbon to the soil. And some of the other speakers are going to talk more about that later on today. So this is another study from the UK, and this one I really like the way that they presented it. So here they've got a pasture, long-term pasture. It's an area it's an area for 16, basically enough forage to feed 16 sheep per hectare. And so what they did in this study is they looked at the sheep that were on top, but they also measured what is the microbiology that we can measure in volume below the surface. I don't know if there's any grad students that would ever want to try and count microorganisms in the soil, but that would be a big job. So when they looked at the springtails and the mites, they had the equivalent volume of 1 sheep per hectare. Mites and springtails are really, really small. You can only see them with a microscope. Nematodes, they had the equivalent of 5 sheep per hectare. Oops. The protozoa was the equivalent of 6 sheep per hectare. Fungi and bacteria, 17 sheep per hectare. Earthworms, 24 sheep per hectare. So when you put all of that microbiology together, you had 16 sheep grazing above the surface, and you had the equivalent of 53 sheep below the surface. So when we're feeding the soil, we're also feeding that microbiology. And this slide, I'm not going to spend any time on it to say that there's diversity in different types of crops, different types of root systems, and so that makes a difference in what kind of microbiology they prefer. So this is a study that we did with a dairy farmer not too far from home. We did it 2 years in a row. Well, no, this is just a picture of it. But where we applied manure, in this case it was anaerobic digestate, to a cover crop. A mix, 5-way mix or 6-way mix. And if you had that kind of a cover crop stand, most people would be pretty happy. But when we added the digestate, we added a lot more biomass on top, but also a lot more biomass in the roots, about 40% different. So then a different study where, again, on a dairy farm with digestate, and here we did it 2 years in a row. After wheat harvest, planted some cover crop oats, and we had one plot where it was just the oats, and then a plot where it was oats with anaerobic digestate. And 2 years in a row, we saw a pretty big difference, about the same amount, about 40% increase in the oat yield where we added the digestate. And so we took feed samples and we put that through the Wisconsin milk program to try and put a dollar value on what is the value in milk from this feed. And so we looked at pounds of milk per ton, so that's more the quality. Then we looked at the yield plus the quality in milk per acre, and then the value of that milk. And basically, we had about a 33 to 50% increase in the milk produced when we had the cover crop with the organic amendment. And we took that one step farther and said, okay, most people are going to harvest this for feed, and it might be oats or it might be cereal rye. But what if we had just plowed it under or had just worked it in and fed the microorganisms with that cover crop? And so what we were looking at is based on the organic matter that was put back, or if we had put it back, how would it compare in increasing the organic matter by 1%? Now, 1% increase in organic matter is huge, so we're doing that just to make it apples to apples comparison. But it would take about 200 applications of digestate to increase that organic matter by 1%, based on the digestate we had with 3,600 gallon per acre rate and the nutrient content that's listed. If we had only cover crop oats, it would take about 26 crops to increase that organic matter by 1%. But the synergy we get when we put the cover crop oats and the digestate together, it would be about 15 times to increase that organic matter. So there is a benefit in that adding the cover crop with the manure. Apart from just the timing when you're applying it and it's not wet and the crops are growing and using that nutrients and you don't have the environmental losses. So that's just an overview of the soil part of manure benefit. It's hard to put a dollar value on it, but there's a lot of advantages to our soil. And most of the time when dairy farmers sell their milk and quota, they'll come up and they'll say, yeah, about 10 years and I really start seeing what benefit that manure had that I'm not getting anymore. The reason that most people value manure so much is for that nutrient value. And this is just a fact sheet. It's a fact sheet that's available online, so I'm not going to go into any detail about it because this information is also available in our AgriSuite database data bank. And What I want to just mention with this, though, is that manure is not created equal. So we have different livestock types that have different types, different compositions of manure, but we also have different stages of livestock, or different dry matter ranges where we've got way more watery manure versus concentrated manure. And so the nutrient content and the nutrients that get provided are not equal. And so it's really important to know what you're working with. Now, fertilizer prices have come down a bit. This is just a graph of fertilizer prices since 2007. Fairly stable for quite a while, and then a couple of years ago took a real nosedive up. And now it's come down again quite a bit. But that doesn't reduce the value of manure. It's still important to look at how can we maximize those nutrient dollars. Now, most of the time when we talk about manure value, we talk about how much nitrogen, phosphorus, potash do we have per ton, or how much do we have per 1,000 gallons. But another way to look at it is, what is the content in our storage? And that depends a little bit. I've got another slide in a few minutes that gives a comparison of different management with the storages. But this is just a typical 1-year manure storage. I'm using MStore from AgriSuite to come up with the numbers. About 1.1 million gallons at capacity. So at capacity, if you look at a typical dairy manure analysis, we would have the equivalent in that storage of about 26.5 tons of urea, about 15.5 tons of MAP, and about 25 tons of potash. That's a lot of nutrients. That's a big pile of fertilizer. But we don't always look at it as fertilizer. We just look at it sometimes as we got to get rid of that quick. And so a couple years ago, 2022, when the prices were high, the value of that, just the nitrogen, phosphorus, and potash potential, and this is available nutrients, or assumed available with proper management, of about $80,000 worth of NPK. That doesn't include the organic matter benefits. It doesn't include the micronutrients. That's just the NPK equivalent. If we did that today, it's about $52,000, so quite a bit lower because the fertilizer prices are down. But still, we have equal micronutrients and organic matter value. Now, some farms have really high soil fertility levels. And so for some farms, if the fertility levels are already high, it might make the most economical sense to sell that manure to a neighbor that's willing to pay for that available phosphorus and potash and nitrogen. Because if you've got high soil fertility levels, it takes a long time before that phosphorus and potash that's being applied this year with the manure is ever going to become available to that crop. You're putting it in the bank, but you're not making use of those nutrients, and you're potentially increasing the environmental risk. So sometimes, if you've got a cash crop neighbor that's willing to pay for those nutrients, that's money in the bank. So one of the other things that we did, just doing some apples-to-apples comparison, and there is no right answer, this is just a consideration, but there's a lot of, especially with hog manure, but a lot of manure that is 2%, 3% dry matter. In other words, 98% water. And if you look at a storage that you build, it's probably there for 25, 35 or more years, and if you're filling it with 98% water, and you're paying $1.50 a gallon to take that manure to the field, over the years, that's a lot of money spent hauling water. So what is the economic benefit, is there one, of putting a cover on it? Not all of, that's not possible with all storages, but where it is, what difference does it make? And first of all, it means that, in this case, I've got an example of an uncovered storage, that same storage covered, and then that same storage covered with no milk house wash water. Now, that takes some planning on its own, but just to show some comparisons. So if I've got 365 days of storage with an uncovered storage, I'm getting an awful lot of water, but if I cover it, then I'm suddenly getting about 460 days of storage, and then if I keep the milk house wash water out, I get another significant increase. But the other thing I get is more concentrated nutrients. So instead of 5.8% dry matter, I'm getting 7 or 8.6. And then my nitrogen, my phosphorus, and my potash are also more concentrated. So I'm taking more nutrients to the field with each load. So I don't know what the cost of putting a cover on. I know it's not something that you can do for every storage, but for those of you that are building a new storage, is it something that's going to pay off over those years? And so we've just put that here for food for thought. So how many of you take a manure analysis? A couple of you? I was hoping everybody's hand was going to go up. It's hard to manage what you don't know. I hope after I give you some of the information on what's in the analysis and why it's so important that you will. But normally with a manure test, we sample for dry matter, total nitrogen, ammonium nitrogen, total phosphorus, and total potash. That's the standard manure analysis. And that gives us some pretty good information on what we can expect for the crop. But there's other things in that manure as well, and especially with different rations, with variation from farm to farm in forage quality. So it's also important to know what some of the micronutrients are. And I've underlined sulfur and copper, but there's also the calcium, the magnesium, the manganese, the zinc, boron. And one of the things in the AgriSuite database is we have thousands of samples, dairy samples included. And so if you go by a dry matter range, it will also, and you've got an actual analysis, it will give you what the average is of whatever number of tests we have in the database. And so if your micronutrients are way different than what's in the database, you might go to your nutritionist and say, is there something that we need to fine tune in our ration? I'm not a nutritionist, but manure is a good, it's almost like a blood test. It tells you if there's something that's out of whack. pH, how many of you have ever tested for pH on your manure? pH is one that we kind of discovered by accident. Anaerobic digestate generally has a very high pH. And we were doing some studies on a forage field, manure on forages, to try and find out what the value was. And the farm went to anaerobic digestate, and so we did the how much ammonia are we losing using dosimeter tubes. And it was a Saturday afternoon, I was showing the farmer, here's the pails, the dosimeter tubes are under the pails. People are going to ask you why you've got a whole bunch of pails in your field. We looked at it, and there was more ammonia loss in the first 2 hours than we get with regular dairy manure in a week at pH 7. And that was an aha moment. And so we started testing pH on a lot of farms, and a lot of pig manure has pH that's near 7.5, 8, or higher. Most solid manure is a pH of 8 or higher. Now with solid manure, because most of it is in organic nitrogen form, not ammonium, then the risk of loss isn't quite as high. But where you've got liquid manure with high pH, it doesn't mean you're going to manage it differently, but if you know that that pH is high, the risk of losing that ammonia nitrogen increases with high temperature, sunshine, and wind. So if we're putting it on, last spring when we were putting out manure in a lot of places across Ontario, it was that really warm week. Suddenly ditched our coats, put on t-shirts because it was warm. That was perfect weather where we were losing a lot of that nitrogen. So if people were thinking, hey, I've got nitrogen for my corn crop, it might not have been there, especially with some of the hog manures in the digestate. Carbon to nitrogen ratio is another one that's especially important for solid manure, but also can give you an idea of availability for liquid manure. And so carbon to nitrogen ratio is basically associated with the bedding or with the cellulose that's in that manure. And it gives you an idea of how quickly is that organic nitrogen being broken down to an available nitrogen. And so the higher the bedding, if I've got a carbon to, anybody know what the carbon to nitrogen ratio of soil is? Any guesses? It's about 8 to 10 to 1. So say 10 to 1 for easy math. So if I have a dairy manure dairy manure that's 9 to 1, 10 to 1, then it's breaking down basically at the same rate that the microorganisms are working in the soil. If I've got anaerobic digestate, that's a carbon to nitrogen ratio of 3 to 1, 4 to 1, 5 to 1, that carbon is going to break down very quickly, that nitrogen is going to be available. If I have a solid manure that the carbon to nitrogen ratio is 30 to 1, well, the microorganisms are going to use the nitrogen. There's not enough nitrogen in the material, so they're going to steal some from the soil. And they're going to give that nitrogen back once the carbon is broken down, but it might not be in time for that corn crop that needs that nitrogen, and so we may have a bit of a nitrogen deficiency short term. So carbon to nitrogen ratio is another one that's nice to know. Organic matter is all over the place. I haven't figured out why such a difference in manure samples. And then total salts. How many of you here apply the manure and then plant right away into the applied manure? A couple of you. So for those farms, that's where the salt content is, and it's called total salts or electrical conductivity. And so it's the ammonium, the potash, and a bunch of different micronutrients and nutrients that add to that salt content. But what we found by accident is if you put a high rate of manure on, especially on sandy soils in dry conditions, and then you plant right away, we can see some salt injury. We did it at the outdoor farm show one year, put on some chicken manure at too high a rate, planted right away, and wondered why we had 6,000 plants per acre instead of 30,000 plants per acre. So I'd rather tell you our mistake than have you do it. So total salts, especially if you're planting very quickly after you apply the manure. How many of you use copper sulfate in foot baths? A couple of you? Okay. So there was a presentation done in Wisconsin at the Manure Expo this past year, and I just took a couple of it was really interesting because we talk about copper. Most of the time we talk about copper in sheep, but the copper in soils, when we apply copper to the soil, that copper is persistent. The only way that copper leaves the soil is through plant uptake. It's negatively impacted with the soil microorganisms, and the safe level in soil is between 5 and somewhere between 20 and 30 parts per million, depending on soil type and soil characteristics. The copper in plants, high copper impacts the root growth. I'm not going to get into details with that, but potentially not as good a growth. And potential for increased concentrations in plants. So if I have high copper in my soils, most of the time that means I'm going to have higher copper levels in my forages as well. So copper tolerance in plants, it's low for pasture grasses and peas, moderate for corn, pretty high for alfalfa and small grains. But the interesting one, and this is, I never knew this until I heard the results of this study, copper sulfate prevents digital dermatitis. And in Wisconsin, in the survey, about 70% of the cows had digital dermatitis. And so copper sulfate works well, and it works well in cold weather conditions, so in conditions like Ontario and Wisconsin. But what I didn't know is that prolonged and high exposure to copper results in some potential liver damage. Now, I don't think most of the time that there's enough copper used. Some of the farms in Wisconsin are huge, thousands of cows. But the recommendations were, if you've got a 12-foot by 2-foot by 4-inch foot bath that has about 25 pounds of copper sulfate, and you've got 250 cows going through that foot bath, it's offered 3 times a week, then in that example, you'd be using about 3,900 pounds of copper sulfate. The copper is 25% of that solution, so you're using about 975 pounds of copper per year. And so then it depends on, okay, how many acres is that manure being applied to? So test the manure plus the application rate. If there's more than 5 pounds per acre per year of copper applied, it's important to monitor. And if there's more than 10 pounds per acre per year, it's important to reduce the use of that copper with some other forms. So that's just a really quick, and this slide was not in the slide deck, it was added afterwards. So just to go on to the next topics, where does manure fit into nutrient planning? And so in my crop rotation, I'm never going to use just manure. I'm going to use a combination of manure plus commercial fertilizer. But where, based on trips over the field and crop rotation and time and some of the other things that I'm doing on the farm, where does it fit? Where how much nutrients are being removed through the rotation, not just by crop, but by full rotation? Where is the manure added? Where is the commercial fertilizer added? And at the end of that rotation, what is the status of fertility in the field? Am I still at low levels? Am I medium? Or am I increasing my fertility levels? And so we have a series of tools called AgriSuite. And one of the tools in the AgriSuite is the organic amendment calculator, or basically the manure calculator. But the other one is a field management plan. And so here what I've done is I've just added corn, soybeans, and wheat. Corn at 210 bushels, soybeans at 60, wheat at 100. Nice yields, but I want to show how much nutrient that removes with the grain. So here we've got nutrient removal with the grain. Over that rotation, using those 3 crops with no manure, no commercial fertilizer added, just looking at the crop removal, I'm removing about 300 pounds of nitrogen, 200 pounds of phosphorus, and 300 pounds of potash. So if I'm soil testing, that would be over that rotation about a 6 part per million reduction in phosphorus and about 15 in potash. So if I do the same rotation, but now I'm going to add manure, and in this case I'm just showing you pig manure just to show differences than just dairy, just in case you don't know what pig manure looks like. So this is from the database, I think, yeah, from the database. Average hog, 3.6% dry matter, applied in the late summer with cover crops at 6,500 gallons per acre. So what we would expect for the following spring would be about 20 pounds of nitrogen per 1,000 gallons, depending a little bit on the weather conditions in the spring, about 23 pounds of available phosphorus, and about 21, almost 22 pounds of potash. So at 6,500 gallons per acre, that would be about 138, 149, 140. And based on current fertilizer prices, that would be worth almost $200 per 1,000 gallons after application. So it gives those information, it gives the kind of nitrogen and what the availability or the losses are. It gives if you've added trace elements, it gives an idea of boron and sulfur, like the different micros that are added. It won't say what the available amount is. It'll just show you what's been added, because we don't know what the availability is. And then if you wanted to override the nutrient cost, you say, yeah, my fertilizer, I'm not paying 78 cents a pound for fertilizer, or 78 cents for nitrogen, phosphorus, and 58 for potash. You can put in your own values. Or if you're paying more or less for your application costs. This is just application. It doesn't include the transport or the agitation. So if I do that with the field management plan, and I put manure after the cover crop, and then I put starter and some side dress nitrogen on based on crop needs, same with the wheat, then at the end of that 3-year rotation, I'm basically balanced with nitrogen, a little bit low on phosphorus and a little bit low on potash. So it would mean that basically my soil test is changing by less than 2 parts per million. So what if I did the exact same thing with a forage crop? So in this case, I've got my seedling year of alfalfa. I've got my first full production year, my second full production year. In this case, I'm not adding any manure or commercial fertilizer. So my nutrient balance after the 3 years doesn't need nitrogen, so I'm not removing nitrogen. But 163 pounds of phosphorus, 750 pounds of potash. This is the reason I'm showing you this. If we didn't add any manure or commercial fertilizer, we would be reducing our soil test for potash somewhere around 35 to 40 parts per million. And I'm going to show you that manure by itself will not replace the amount of potash that gets removed in hay crops. So this is a dairy manure, so if we applied this several times, every time that we had an opportunity after we take a cut off, we're getting, in this case, about 8 pounds of nitrogen, 8 pounds of phosphorus, and 28 pounds of potash. I'm not giving it the same value because the alfalfa doesn't need that nitrogen, but if it was a mostly grass hay or a grass alfalfa mix, then the nitrogen would definitely make a difference for the grasses as well. So at an application rate of 3,500 gallons, 3 times during the summer after hay, same kind of thing as before. It shows the sulfur, you're getting about 7 pounds. So here I've got manure applied after each cut, and so at the end of the 3 years, 11 pounds of phosphorus, so I'm pretty balanced on my phosphorus, but with that average dairy manure, I'm still not supplying enough potash. I'm still reducing that potash soil test by about 16 parts per million over that rotation. Question?
Sorry, I can't see from back here. What's your forage yield in that?
My forage yield is 3 cuts, 5 tons per acre. which is a pretty average yield. And so with the manure, I'm adding about the same amount of sulfur as what's being removed. Apply manure to forages. Okay, so a lot of you. So manure on forages, we've done a fair bit of work on looking at manure on forages. And we did the study because we wanted to make sure that manure wasn't decreasing the yield of forage harvest or forage yields. But what we found, first of all, nutrients to growing crops, it prevents some of the environmental losses, including greenhouse gas emissions, because greenhouse gas emissions are reduced when you're applying manure to growing crops. The microorganisms use it very quickly. We supplement the phosphorus and potash that got removed with the harvest, although not all of it, obviously. We can supplement nitrogen for the grasses in the rotation. We save on commercial fertilizer dollars. We reduce our storage requirements compared to just applying once per year. We spread out that workload for manure application, and we reduce the compaction that we would normally get if we were putting manure on in the spring. But the best part is we also increase by about 10 to 15% the yield and the quality of our forages. And so this is a bunch of studies that were done over about a 10-year period. Some of them were done with just the surface applied versus nothing. Some were done with surface applied versus commercial fertilizer versus nothing. And so that's why we've got the different charts. But generally speaking, we had about a 7 to 11% increase, 12% increase in forage quality compared to just a control, just a check. And we still got better with the manure than we did with just the fertilizer. Now this is just a quick video that this is European equipment. It's a dribble bar or trailing shoe, depending on what company you're talking to. It applies manure in about a 8-inch to 10-inch width, but it's applying it right at the surface. So we're not getting any losses. We're getting the manure applied right where the crop needs it. Less volatilization losses if you've got a little bit of canopy there, getting fairly quick infiltration. And so this is a nice way to be able to apply manure to a field. And I think this is European. They had some of the restrictions in when manure can be applied a lot sooner than North America. So they've already done the work on finding the best equipment. And this to me, this is a nice piece of equipment in that injection is great, but it requires horsepower, and sometimes the soil conditions are too wet to make that a real option. Here we've got a relatively wide boom, anywhere from 50 to, in Europe they have them at 120 feet. And so you've got basically a fair amount of acres that you can cover in a short amount of time. One of the things though with this kind of equipment is you can't put garbage in the storage. Some of the custom applicators that have used this equipment, they say the Tim Hortons cups, the insemination straws, they make the plug-ups terrible. But the solids in the manure haven't been a problem for most of the manure. So this is the type of equipment that's becoming more popular. If there's grant programs through SCAP where people can look at different equipment, this is one that would be good to consider or compare. So applying manure to forages, we've got the right place and we've got the right time. The right place means applying the manure ideally to the fields that need the fertility the most, fields that have the lowest soil fertility. Surface applied versus shallow injection. Shallow injection was nice, but it takes more horsepower, and if you've got an airway that you're doing that shallow injection with, you're going to bring up stones. So don't use an airway. We found that out the hard way. And then if you have risk of yonis, then apply it to ensiled hay and not to wrapped bales that are going to heifers or to calves. Timing's critical. So if we can apply as soon after harvest as possible, that's our best bet, and I'm going to show you in pictures why. In this picture, we cut day 1, we harvested on day 9 because it was wet weather. Day 11 was the manure application, and you could see that we already had quite a bit of regrowth and we had a fair bit of tire tracks. And where we had those tire tracks and where we looked at the yield in those tire tracks at the next cut, we had 32 to 49% reduction in yield just in those areas. A little bit higher quality because it wasn't as mature, but less yield. And so when we think about how many times we have traffic over the field and when is that traffic happening, if we get this kind of tire track damage, that's significant. And especially if it's relatively narrow spread widths and we've got a lot of those tires. But there's a lot of different equipment that goes over the field. It's probably a good idea to limit it as much as possible. The other thing that we would probably not recommend is putting manure on new seeding. I would never have had the guts to do a side-by-side comparison on this, but one of the farmers that we work with was curious to see what it would do. And there's definitely a yield decrease, not only the seedling year, but also the year after. And the reason for that is when we have a new seeding, every single plant is going to grow a crown. And if we take those plants out early, we're reducing all the potential crowns from that planted. So we're reducing that stand over a longer period of time than just the first year. So full production year is great, new seeding, not the best time. So the reason that tire tracks are a problem, or going over a field where there's already some regrowth, when we get regrowth, we've got those old stems, and we get new growth from those stems. And if we drive over those stems when there's already some regrowth, then basically we're making that plant start all over again, mostly from the crown. And that's where we're losing that yield. And this is just a little bit better picture. So this is the apical buds on the stem, growth from the crown. And if we only have the crown growth in those wheel tracks, we're just not getting the same yield potential. So this is a field that we did some studies on in the beginning of COVID. Really dry spring. So this was a week after the manure application, the regrowth, both the grasses and the alfalfa. Less than an inch of rain since the first cut. And then this was the in the wheel tracks. So growth in the rest of the field, growth in the wheel tracks, quite a bit less. And this was the regrowth 2 weeks after. So that manure provided quite a bit of water benefit as well. So just to summarize, 4 hours of manure application to forages. The right source obviously is the manure. The rate not too high that you're going to burn the crop, so not too much ammonia. And then the right time as soon after cutting as harvest as possible, and the right place the fields that need it the most. How many of you use sand? Okay, not very many. So I'm not going to spend a lot of time on sand. There's going to be a little bit of discussion about sand this afternoon as well. But sand is hard. Sand is hard on equipment. Sand is hard on storage management. But the other thing that sand does is it adds a lot of inert material to your manure. We did a study with Jack Rodenberg and Harold House several years ago, and there's a really strong relationship between the dry matter and the sand content. And so what we could figure out is if I have a sample that's at 10% dry matter, then based on that equation, I've got about 5% sand. So that means 500 pounds of sand per 1,000 gallons with this example. That's a lot of sand that we're taking back to the field. Now that's assuming that it's all mixed. That's the trouble with not mixing the sand is that you're displacing volume at the end. So that's the sand content at 10%. Sand content at 5% dry matter is about 200 pounds per 1,000 gallons. At 30% dry matter, about 400 pounds per ton. So sand is hard to manage because it's hard to get clean, it's wet, it's hard to manage, and it's hard on equipment. Anybody here use anaerobic digestion? Okay, I'm going to skip over this one then. Anybody doing separated solids? I'll skip over that one as well. This is one that's gaining a little bit of popularity, especially with dairy farms that like to put manure on after forages because they can They can basically, with intermittent aeration, the storage is always ready for application. You don't have to do any agitation. And so they can go in and after harvesting some hay, go in without having to agitate not too much planning. Plus, it reduces methane and it reduces the hydrogen sulfides. Anybody doing composted bedded pack barns? Okay, a few of you. So this is another one that's fairly new technology. We're learning a lot. We've done a couple of Manure Mondays on it, and we're planning to do another Manure Monday on composted bedded pack barns. Christoph Wand and Tom Wright are probably the experts within OMAFRA on it. But if it's done properly, somatic cell counts is one of the things that people are especially conscious of. But you've got high organic matter, you've got soil benefits. The nice thing about this compared to, let's say, anaerobic digestion, where you've got a manure, anaerobic digestion is a little bit like taking dairy manure, putting it through the anaerobic digester, and ending up with something that's the composition of pig manure. So a lot higher ammonia, higher pH, lower organic matter, and a lot lower dry matter. So here you've got basically a material that you can store so that it's applied at the right time in the year. It's fairly high in nutrient content because you're reducing the volume of the manure so that the volume is reduced but the nutrient content is higher. And it allows for temporary storage for application during the best times. I think I said that already. So now I'm going to get into a little bit on utilizing our manure for best availability. And when we test our manure, we've got our organic nitrogen, which is the slow release nitrogen, and then we have the ammonium nitrogen, which is like your quickly available. The plants can use it just as ammonium, or within a couple weeks during good growing conditions, it converts to nitrate, same as your fertilizer. The trouble with the ammonium is it can be lost through volatilization fairly quickly. And so we look at, okay, what can we do to improve that availability? And so some of the considerations to maximize availability, what are the things that influence both availability and losses? One of them is timing of application. When is the best time to apply? Is it in the fall? Is it in the spring? What is the best place? Is it surface applied, or is it injected, or is it incorporated quickly? And you might be surprised at the answer to that. What are the nitrogen credits? And can we use nitrogen inhibitors? Can we use them for commercial nitrogen the same as we can for manure? And then, of course, weather. Weather impacts everything. But remember I showed you that dribble bar where that manure is placed right at the surface. Well, here is splash plate, relatively windy day, and you can see the droplets that are moving with that manure. Lots of times it's dust that's behind it, but in this case it was those small droplets. That's what you smell. It goes a long way. The bottom here, this is a picture from last spring near my place, and there's a lot of water in this field. There was manure spread in this field. This isn't our field, but manure spread in this field. If I was the farmer farming this field, I would wonder, how much of that manure is still where I put it? And how much of that phosphorus is now concentrated in that low area? So those are the kind of things we're trying to avoid. So how can we apply the manure so that we get the maximum use out of those nutrients? So this is probably a slide that you've seen before, but what I want to show you here is liquid manure and solid manure are different in availability. Solid manure, because we have the biggest proportion of that nitrogen is organic nitrogen, or that slow release nitrogen, we get more of that, because it's got a higher carbon to nitrogen ratio, we get more microbial activity working on that manure in the late summer, late fall, early spring. So we have the maximum amount of nutrients available, nutrients available when we apply the solid manure in the summer or late fall, with a cover crop, of course. Where with liquid manure, because most of it is in ammonium form, we have the potential to lose that with fall applications through volatilization or moving below the root zone with the water. And so our best application with those liquid manures is in the spring, where possible, or late fall if we've got clay soils. And the reason I say late fall is because once the soil conditions are cooler, once we get below 10 degrees Celsius, the microorganisms in the soil slow down. They're not as active as they are when it's warm conditions. And so when those microorganisms slow down, they don't convert that ammonium to nitrate, so that ammonium stays in the soil better. So if spring application, because we've got clay soils or heavy soils, isn't an option, then later fall application, ideally incorporated, is your best bet. So our goal is to have the highest amount of nitrogen available during the period when the crop needs it the most. Now, everybody's always in a hurry to get their nitrogen on at side dress before that corn starts getting taller. Because we know that that corn, once we're at that 6 to 8 leaf stage, that corn shoots up very quickly. And that's the point in time where the nitrogen needs are the highest. So how can we ensure that as much of that nitrogen from our manure is available during this period of time? And if we've got the type of manure that's not going to release that amount of nutrients, then how much commercial fertilizer do we need to add, or at what point do we need to add it, as side dress or up front? And that's the same with wheat. With wheat, we've got that elongation stage of the wheat where it needs the maximum of its nutrients. The only trouble is, with corn, this is that, I don't know, mid-June to late July period. With wheat, it's a month earlier when the soil conditions are cooler and when the microorganisms aren't quite as active yet. And so with cover crops, I get asked all the time, how much nutrient is going to be available with my cover crop? And we always compare everything to the red clover or to the alfalfa. Alfalfa is even higher than this, but we get a nice nitrogen credit from those crops because they release that nitrogen when the corn crop needs it the most. All the other cover crops, we get a nitrogen benefit, but it's hard to give a nitrogen credit where we can reduce our commercial fertilizer. So really what we're getting is we're feeding the microorganisms, we're getting better nutrient cycling, but we can't count on that nitrogen being there for that crop and reducing our commercial nitrogen. And again, we're talking about carbon to nitrogen ratio. If I have a cover crop that's at vegetative stage, so say oats or cereal rye, vegetative stage, I'm going to have more green material, less cellulose, lower carbon to nitrogen ratio. If I have that same winter cereal and it's headed, I've got more cellulose, more lignin, higher carbon to nitrogen ratio, so it's going to take longer to break down. But if I put manure on that same mature cereal, winter cereal, then I've got more biomass, I've got more nitrogen content because I've got manure in that biomass, and so as a result, my carbon to nitrogen ratio is going to be a little bit lower. So where I've applied manure, that availability is going to be a little bit quicker, but we can't say how much is actually going to be available or when, because it depends on so many different factors in the soil. So when we're looking at nitrogen management, and we're looking just at commercial fertilizer, and I can just say that there's probably, we always say that 100% of the manure should not be, or 100% of the nitrogen should not come from manure, because the timing and the availability is just not going to be there. So we're going to have some commercial nitrogen, we're going to have some manure nitrogen, hopefully. So how do we manage it for its best? So with commercial nitrogen, the strategies are always, okay, how much does the corn need? We go to the corn calculator, we take our legume credits, we take our manure credits into account. If we're injecting or banding that nitrogen, then we usually can reduce the rates a little bit because it's there where the crop needs it, we're not losing any. So it can be anywhere from 45 to 7%, depending on what the temperature is. If we side dress versus put everything up front, we can reduce our nitrogen requirements by about 20%. If we use nitrogen inhibitors, depending on when and what kind, we can reduce, and depending on the weather, we can reduce our nitrogen, or have nitrogen savings of about 40%. Probably not usually that high. So if we do the same thing with manure, okay, how can we maximize our efficiency with manure? Well, the same thing. We use the recommended rates for our corn crop. We test the manure so that we actually know what nitrogen availability we can get. We might reduce that a little bit based on weather conditions, because if it's a cold, backward spring, we're not going to get as much availability as if it's a nice, remember 2012 when everything started in March? That year nitrogen availability was huge. We don't get that every year. Incorporating the manure versus surface broadcasting, we can get a 30% nitrogen savings. Utilizing the manure credits, how many of you realized that you get manure nitrogen credit the years after application? A couple of you. So especially with the solid manures, that organic portion, only a portion of it's available the first year, then we get another percentage of it available the next year and the next year and the next year. So if we're applying manure on a regular basis, those credits, especially with solid manure, can be quite large. And that could be up to a 17% nitrogen savings. Timing of nitrogen, so if we can apply it at side dress time, now probably that's not going to be something we would do with dairy manure, just because dairy manure tends to be about 50% organic nitrogen, 50% ammonium. So we generally have a higher carbon to nitrogen ratio, and it might not work with side dress as well as pig manure or anaerobic digestate would. But if we put our nitrogen up front and we don't know exactly how much is available, we can use the pre-side dress nitrogen test and then potentially put some additional commercial urea 28 or whatever form we like, UAN. Use of nitrogen inhibitors. John Lozon did some trials with it. The trouble with the nitrogen inhibitors are that they don't last long enough. So they break down about 3 weeks afterwards. And so if we use them in the fall to try and save that nitrogen, they're still going to be gone by spring. And there hasn't been enough research done yet on manure applied in the spring to see what that benefit is. So until there's more research, I'm not sure that I would be using nitrogen inhibitors in the manure. With the commercial fertilizer, sure. So I've got about 5 minutes left. So just a couple of trials that so here is yield impacted from injected versus surface applied. This is a picture I took off of the internet that one of the custom applicators put up. But they were saying that anything that was in the green and the dark green was injected, and then the reds and the oranges, that was surface applied. And so they didn't give any details, but what would be the potential reason for more losses where it was surface applied? Probably more ammonia loss, maybe because of high pH, maybe because it was sunny and high temperatures. I don't know the reasons, but that's the kind of thing that you would potentially expect. Then there was this is a study that one of my counterparts did with one of their growers in North Gore. This is in the Ottawa area, and it's pretty neat. They did the fertilizer treatment, they did the manure treatment. So everything was the same up front, the same pre-plant fertilizer, the same starter fertilizer. The fertilizer treatment got commercial fertilizer surface applied at 6-leaf stage, 4,000 gallons of beef feedlot manure. This is pretty rich feedlot manure. This is richer than most dairy manure, and that's a pretty high rate. That's probably more nitrogen. I think if I was looking at this and doing this again, I would say maybe we don't need that. Anyway, so then the nutrients applied in total, 184, 61, 23, 273, 340, 183. Obviously more nutrients than the crop is going to need this year, so there's some for next year. Yield difference, 30 bushels. Nutrients removed, the balance at the end of the year. So with the fertilizer only, we're a little short on the phosphorus, but we've got enough nitrogen and potash. With the manure treatment, more nitrogen, we've probably lost some. We've got some extra potash for next year, so it depends on where the fertility levels on that field were. In this case, it was 20, so we're doing some buildup. 115 for potash, so we don't need a lot of extra commercial fertilizer. The economics, so this is just taking relative prices from last year. So grain minus the drying and trucking, minus the fertilizer, minus the side dress application, $675 versus $830, and we've got some fertilizer value for next year. So this is a plot that they're going to do again this year to see, and they're going to try, I think they're going to try and reduce the upfront to see if we really needed that. We're also going to do some dosimeter tubes to see what the nitrogen losses are. But side-by-side comparisons tell us a lot. So this is one where strip till, this is one where strip till is kind of cool. You make the strips in the fall or in the spring, and once we figure out how to do the strips in just for corn planting, maybe we can figure out how to do strips, put some manure down in the fall, plant right into those strips in the spring, and we don't need the starter fertilizer potentially. So this is one of my counterparts in Ohio, Glenn Arnold. He does a lot of really cool research. And so he did this study with swine manure and with dairy manure. All the treatments received 200 pounds of nitrogen as 28% at side dress time. Now I would question if that was actually necessary, but this is a study. They're trying to see if there's any any harm to germination or emergence, and so they were just doing a basic trial. So swine manure at 4,200 gallons, at 6,700 gallons, dairy manure 6,700 gallons and 10,000 gallons, supplying 200, 320, 128, 192 pounds of nitrogen. They did that study for 3 years. No fall manure, also got no starter because they didn't put any starter up front. And so it just gives an idea of the yield differences. And so needless to say, we're getting some pretty nice yields just from being able to put that fertilizer down. And like I said, if I was doing this study again, I would probably do the pre-side dust nitrogen test and see whether we really needed that full 200 pounds. Compaction, most of you are aware of some of the compaction research that's going on. And so I'm just going to summarize. So we've got this commodity called manure. It's got a lot of value. It adds complexity. It adds extra management. But keep in mind that the cost of manure is part of your livestock business. So the better job we do of managing that manure, the better it is to that bottom line. So we look at what is the nutrient content and what is the not just nitrogen, the nutrient availability based on our rotation, our site conditions, and where we apply manure in that rotation. Do we have manure credits that we can count on? Are there additional fertilizer requirements based on our fertility levels? If we're at low fertility, if we're at high fertility. And most dairy farms that I've been doing soil tests on, the phosphorus and the potash levels are generally pretty low compared to hog operations or poultry operations. The importance of manure testing, you can't utilize what you don't measure. So if there's one take-home message today, test your manure for more than just the NPK. Manure nutrients should never supply 100% of the crop nitrogen needs because you're going to start getting imbalances in your phosphorus and your potash, plus the potential for losses is a little bit too high to the environment. 4R management will give you the highest manure value. Right timing means as close as possible to growing crops, and that includes cover crops. Right place, I'm going to say the right place more than injection or surface applying is basically to the fields that need the nutrients the most. And sometimes logistically that's hard. And so when we talk about maximizing manure nutrients, maximizing every fertilizer dollar isn't always possible. We also have to consider the logistics on the farm. What is your rotation? What are the other equipment, labor, rotation, whatever, that's happening on your farm that might be unique? Soil conditions, all those kind of things. So it's not always maximum economic dollar from a fertilizer perspective. It's maximum economic dollar based on your situation. And so, and then the last thing, I started with this and I'm going to finish with it, manure contributes to that better soil health on our farms. So any questions?